Of the application of power screws, the load is lifted by the screw jack or to clamp the workpiece, example vices, or to move the tool during machine. So that means lead screw of lathe. Okay, hence, so based on the type of operations, we should consider the concerned stresses. Okay, so some of the stresses induced in the screw rod are as follows. Okay, so the powered screws must have so greater strength to withstand axial load and so applied torque. Okay, so these are the that means this is the first type of stresses induced in the screw rod. Okay, so what is the first one? So direct or compressive stress due to axial load. Okay, so we know that stress formula, that means compressive stress formula, sigma C equal to W by AC. Okay, so by using this formula, so calculate the compressive stresses. Okay, so W means load, that means axial load or compressive load. The next one is AC, so AC means area. Okay, so AC equal to what is the formula? Pi by 4 into D square, that means DC square. Pi by 4 into DC square. Okay, so DC means core diameter or so root diameter. Okay, so in case, so this formula used for short length of rod. So in case if the length of rod is too great, okay, so then so there is a chance for buckling under compression. Okay, so already you know the bucklings. Okay, so whenever the length of rod is too large or too great, okay, so under cases, okay, so there is a chance for buckling under compressive load. Okay, so by using this formula, that means FCR, so FCR means buckling load, okay, equal to so pi into DC square into sigma C by 4 into 1 plus A into L by K whole square. By using this formula, so calculate the so FCR or sigma C. Okay, so then A is the constant, then A equal to 1 by 7500 for steel. Okay, so this A value so depends upon so materials, this A value depends upon materials. Okay, so next one is this FC formula, and then next one is sigma C formula. Okay, so these two formulas completely so given in data book. Okay, so Jalaluddin data book, so data book page number is 9.14, the equation is 9.17. so L means so equivalent length of the screw rod. So this L value so depends upon 4 conditions. Okay, so please see the 4 conditions in data book. Then so L equal to L for both hands or injured. In case of both hands or injured condition given in question, then use this equation L equal to L. Then next one is in case of both ends are fixed given, then L equal to L by 2. So one end is fixed and other end is hinged, then capital L equal to L by root 2. In case one end is fixed and other end is free, please use this formula L equal to 2L. Okay, so substitute small l in this equation. So after that this L value substitute in so FCR formula. Okay, so this is the so one type of stress induced in the screw rods. Okay, so what is the first stress? So direct stress or compressive stress. Okay, so then next one is the screw is a rotation is there. What is the mechanism of screw? The rotary motion is converted into translatory motion. Okay, so on that basis some amount of torsional shear stress occurs in the screw rods. Okay, so how can you find out the shear stresses? So we know that one formula, torque formula, then T equal to pi by 16 into tau into DC cube. Okay, so the screw is subjected to twisting moment. Okay, so then so this formula also already given in data book, then data book page number is 9.14. Okay, so Jalaluddin, then equation number is 9.18. Okay, then so when the screw is subjected to both direct and torsional shear stress, okay, so then so maximum stress equal to 1 by 2 into sigma C plus under root of sigma C square plus 4 tau square. Okay, so in case of the screws or both stresses, that means sigma c, direct stresses or compressive stress. The next one is shear stress. Please use that formula. Okay, that means sigma maximum. Okay, so then next one is maximum shear stress. We know that one formula, so tau maximum equal to 1 by 2 into under root of sigma c square plus 4 tau square. Okay, so these one, then torque formula, then sigma maximum formula, then so tau maximum formula also, so given in data book. Okay, so please see the formulas. The page number is 9.14. Then so torsional shear stress in the screw rod, then tau equals 16 into TR by pi into DC cube. Okay, so we know that actual formula T equal to pi by 16 into so tau into DC cube. Okay, then so maximum principal stress in the screw rods, so in case of that means combination of sigma c and tau. Okay, so please use this formula. So then so tau maximum, so maximum shear stress calculation, then so maximum principal stress calculation. Okay, so the next one is so tau, so this formula also very important. So for calculation of factor of safety, then factor of safety equal to so tau y by tau maximum. Okay, so then so tau maximum equal to tau y by so factor of safety. Okay, so these are all formulas used for so find out the stresses in screw rods. Okay, so first stress is compressive stress or direct stress. Then second stresses developed in the screw is torsional shear stress. Okay, so next one is both direct and torsional shear stresses. Okay, then next one is so third one. Okay, so third one is the shear stress due to axial load in threads. So these two stresses, that means compressive or direct stress. Then next one is shear stresses. Okay, that means torsional shear stresses developed in the screw rod. Okay, so this third one is the shear stresses in threads of screw rod. Okay, that means the stresses in threads. Okay, so how can you find out the stresses in screw threads? By using this formula, then tau screw equal to W by pi and DC into T. So W means load, so N means number of threads, so DC means core diameter, small t means thickness or so width of the thread. Okay, so this formula is used for stresses in screw. The next, in case of the stresses in the nut, so tau nut equal to W by pi and so D naught into T. Okay, so W means a load, N means number of threads, D naught means outside diameter or nominal diameter or major diameter, then small t means thickness or width of the thread. Okay, so by using these two formulas, just found out the shear stresses in screw threads, shear stresses in nut. Okay, so then finally so bearing pressure. Okay, so this is the formula of bearing pressure. So what is the use of bearing pressure? So why we are calculating bearing pressure? Okay, so in order to reduce wear of the screw nut, the bearing pressure on threads. Okay, so what is the main use of bearing pressure? In order to reduce wear of the screw nut. Okay, so then PB, so PB means so bearing pressure equal to W by pi by 4 into D naught square minus DC square into N, or so W by pi and dt. Okay, so T means thickness, D means nominal, that means mean diameter. The next N means number of threads. Okay, so T value. So how can you find out the T value? So we know that one formula, then T equal to pitch by 2. Okay, so then N equal to, so just in case of some competitive exams, they will give so calculate so number of threads, so height and pitch, so they will give in question. Okay, so calculate the N. So how can you calculate the N? So by using this formula. Okay, so N equal to H by pitch. H means height of nut, then pitch. Okay, so already you know the pitch. Okay, so these are all stresses are developed in screws and screw threads. Okay, so first one is direct stress. Okay, so please see the data book. Direct stress, this is the condition number 1. So then, so calculate the direct stress by using this formula. Okay, so for shorter rods, in case of longer rods, okay, so please use crimping load formula. Okay, so then next one is next stress, the torsional shear stress in screw rods. Okay, T equal to pi by 16 times dc cube. Then, so next calculate the maximum principal stresses, that means combination of sigma c and tau, then maximum shear stress. Okay, so after that, so calculate the tau s. So tau s means the shear stresses in the threads. So these formulas are used for screw rods. So these two formulas used for threads of screw rod, threads of nut. Okay, so finally, so bearing pressure. Okay, so then FB equal to WY pi N dt. Okay, so N equal to number of threads, so T equal to thickness. Okay, then T equal to formula, so pitch by 2. Okay, so these are all so different types of stresses are developed in power screws. Stress related problem. A power screw having double start square threads of 25 mm nominal dia and 5 mm pitch is acted upon by an axial load of 10 kN. The outer and inner dia of screw collar are 50 mm and 20 mm respectively. The coefficient of thread friction and collar friction may be assumed as 0.2 and 0.15 respectively. Okay, the screw rotates at 12 rpm, assuming uniform wear condition at the collar and allowable bearing pressure, so 5.8 Newton per mm square. So find so torque required to rotate the screw, the stress in the screw. Third one is number of threads of nut, okay, in engage with screw. Next, so the power screw having double start, so this condition is very important. Then square threads of 25 mm nominal diameter. So what is the symbol of nominal diameter? D0. 5 mm pitch, that means P, is acted upon by axial load, that means W. Outer and inner screw collar, okay, so that means D1, D2 collar diameters, outer diameter and the inner diameter. The coefficient of thread friction, collar friction. Thread friction means mu, collar friction means mu1. Okay, the screw rotates at 12 rpm, that means N speed. Okay, so then next bearing pressure, that means PB. So PB means bearing pressure. Okay, then find so torque. So torque means capital T. Then next the stress in the screws. Okay, so calculate the stresses in the screws. Sigma C, tau, then sigma maximum, then tau maximum. Okay, then third one is number of threads of nut in engaged, that means calculate so N. Okay, so this is the question. So first one is condition number 1, so calculate T. Condition number 2, so calculate the stresses, sigma C, then tau, then sigma maximum, tau maximum. Third one is N. Okay, the next, so this is the so given data. Next, so nominal diameter, pitch, load, kilo means 10 power of 3. So D1, so collar outside diameter, then radius, so D1 R1. Next D2, so collar inside diameter, then R2. So mu, coefficient of friction of screw, then mu1 collar friction, then N speed, then PB, so bearing pressure, then so torque required, stresses, then so N equal to question mark. So this is the complete given data. Then next, so condition number 1, so torque required to, so condition number 1 is so So torque required to rotate the screw. Okay, so condition number one is so calculation of torque required to rotate the screw. Okay, so what is the formula of torque? So T equal to force into perpendicular distance. Okay, so please take the total torque. So T equal to, this is the T1, then so T2 equal to mu1 into W into R, then torque equal to T1 plus T2. So this is the total torque. So why we are taking T1 plus T2? So the collar related data given in question, so that's why. So please consider collar related. Okay, so torque. Then next, so T1 equal to formula, then T equal to T1, so P into D by 2 plus T2 equal to mu1 into W into R, then so R equal to formula, so mean radius R1 plus R2 by 2. Okay, then so T equal to P means W into tan alpha plus pi into D by 2 plus mu1 W into R. Okay, so T equal to W into tan alpha plus pi into D by 2 plus mu1 W into R1 plus R2 by 2. Okay, so this is the final formula of torque, W. Okay, so given in question, W, given in question, W. Okay, then this is the known value. Next one is alpha, so not given, unknown value. So pi, unknown value. Small d, so this is also unknown value. Then mu1, so known value. Okay, so W also known value. Then R1 and R2 also known values. Okay, so in this equation, so alpha and pi and d, so small d, so these three values are unknown values, so calculate alpha and pi and d. So after that substitute in T formula. So we know that one formula, so tan alpha equal to pitch by pi d. Okay, then next, so we know that another formula, so tan pi equal to mu, then alpha equal to tan inverse of pitch by pi d. Okay, so just calculate alpha value, so you can directly substitute in this equation alpha. Then next, so pi equal to tan inverse of mu, so mu already known value. Okay, so calculate the pi. So after that substitute in above equation. But so in this case, so small d is unknown value. So in this question, so d0 is given. d0 means nominal diameter, small d means mean diameter. So but how can you calculate the d value? So we know that one formula, so d equal to d0 minus pitch by 2. By using this formula, so calculate d. So after that substitute so in this formula or equation. Okay, so this is the procedure. So how to calculation of torque. Okay, so then T equal to, final formula is T equal to T1 plus T2. Okay, so why we are taking T1 plus T2? So okay, so this is the torque required to in screws. Then so T2 is, so then next the T2 value is related to collars. Then so T1 plus T2 equal to total torque. Okay, so in case of without collars, then torque equal to T equal to T1. Okay, but in this question, so collar condition also given. Then so T1 equal to P into D by 2, so T2 equal to mu1 into WR. So P means W into tan alpha plus pi so into d by 2 plus mu 1 into wr. Then so w known value, alpha, pi, d unknown values. Okay, so that first calculate the tan alpha, tan pi, that means alpha, pi, by using these two equations. Okay, so d is the unknown value, but how to calculate the d value? By using this equation, d equal to d naught minus pitch by 2. Okay, so this is the procedure. Then next, substitutions. Next one is substitutions. Next one is substitutions. Then so tan alpha, first calculate the tan alpha. So tan alpha equal to pitch by pi d, but d is the unknown value, so d equal to d naught minus pitch by 2. Then d equal to, so d naught equal how much value? So 25 mm. So d naught equal to 25 mm. 25 minus, in terms of mm, pitch equal to 5 mm, 5 by 2. Okay, then small d equal to, that small d equal to, so 22.5 mm. This is the value of small d. Okay, so after that substitute in tan alpha. Then tan alpha equal to, so pitch 5 by, so pi into 22.5. Then so tan alpha equal to 0.1414. Then alpha equal to, so tan inverse of 0.1414. Then alpha equal to, alpha equal to shift tan inverse of tan 0.1414, 8.048 alpha. Okay, then next, second condition. So tan pi equal to, so mu, then pi equal to tan inverse of mu. Then mu equal to, what is the value of mu? 0.2. Okay, then tan inverse of 0.2, pi equal to, so 11.3. Okay, so pi value and alpha value so completed. Okay, so the next step, the next step is step. Okay, then alpha equal to 8.048, then pi equal to 11.3. Okay, so then t equal to t1 plus t2, then t1 equal to, so p into d by 2, then so p equal to w into tan alpha plus pi into d by 2, then w equal to how much? Then w equal to 10 kilonewtons. W equal to 10 kilonewtons, that means 10 into 10 cube into, so tan 8.048 plus 11.3 into small d equal to 22.5 by 2. Then so t1 equal to, so 10 into 10 power of 3 into tan 8.048 plus 11.3 into 22 into 22.5 by 2. Then T1 equal to, so 39502.77 in terms of Newton mm. In terms of Newton mm. The next, so then T2. So T2 equal to, so mu1 into W into R. So mu1 equal to 0.15. So given in question, load equal to 10 into 10 cube into R, that means R1 plus R2. So R1 equal to 25, then R2 equal to 10 by 2. Okay, 35 by 2 into 10 into 10 cube equal to 26,250. So Newton mm. Then T equal to T1 plus T2, 39502.77 plus 26250. Okay, then T equal to 39502.77. So 65,752.77. So Newton mm. So this is the total torque. Okay, so first condition is completed. So convert into in terms of meters. 65,752.77 into 10 power of minus 3. So Newton meter. Okay, so this is the procedure of calculation of torque. Okay, then next, second condition. So what is the second condition? Second condition is, so calculate the different types of stresses. That means calculate the stresses. Condition number 2, stresses. Okay, so then next, so first one is direct stress. Okay, so we know that one formula, sigma c equal to W by AC. So W by AC means pi by 4 into DC square. Okay, but DC is the unknown value. So how can you calculate the DC? So we know that one formula. So DC equal to D naught minus P. So D naught equal to 25 minus pitch, then so 20 mm. So DC equal to how much? 20. Then load 10 into 10 power of 3 by, so pi by 4 into, so 20 whole square, then equal to, so 31.83. So Newton for mm square. Sigma c completed. Okay, so then next one is shear stress. Pi by 16 into tau into d cube. Okay, so then tau equal to 16 into t by, so pi into d cube. Okay, but how can you calculate the shear stress? By using the torque formula. We know that torque equal to pi by 16 into tau into, so d dc cube. Then so 16 into, so torque equal to how much? Then torque already completed. So 65,752.77. 752.77 in terms of Newton mm by, so pi into DC cube, 20 whole cube, then tau equal to, so 40 into 16 by shift to pi into 20 cube, then 41.859 Newton for mm square. So this is in terms of mm. Okay, then so shear stress completed. Then next one is third one. So maximum shear stress in the screw. Next, calculate the maximum shear stress in the screw. We know that one formula, tau maximum equal to, so 1 by 2 into under root of sigma c whole square plus 4 tau square. Okay, sigma c equal to how much? 31.83. Then tau equal to 41.859. Then tau maximum equal to, so 1 by 2 into under root of 31.83 whole square plus 4 into 41.859 whole square. Then tau maximum equal to, so 44.8 31.83 whole square plus 4 into 41.859 whole square, 44.78 or 8 Newton for mm square. Okay, then next, so two conditions completed. So first one is torque, then second one is stresses are developed in the screws. Okay, first one is direct stress, so calculate the direct stress by using this formula. Then sigma c completed. So then next one is shear stress in the rod. The next one is maximum shear stress. Okay, so then finally, so third one is number of threads of nut in engaging, that means engagement with screw. So that means, so calculate the number of threads, that means small equal to n. So we can easily find out the small n value from, so bearing pressure. Okay, so how can you calculate the small n value? So with the help of bearing pressure formula, Pb equal to W by, so pi into d into t into n. Okay, so W equal to how much? So 10 into 10 power of 3 by pi into, so then small d equal to 22.5. Okay, then so thickness is unknown value. We know that thickness, so t equal to pitch by 2, so pitch equal to 5 by 2, then so 2.5, then small t equal to 2.5, then n is the unknown value, calculation value. So Pb equal to already given in question 5.8, then n equal to, so 9.76, that means approximately, so 10. The number of threads of nut in engagement, so with the screw. Okay, so this is the calculation of stress and number of threads, okay, and torque. Okay, so once again I repeat. Then so this is the given data. So this is the given data. So D naught means outer diameter, pitch, load, axial load. So outer diameter of collar, radius, outer radius of collar, inner diameter of collar, inner radius of collar, the coefficient of friction, so between the screw and nut, so coefficient of friction with the collar, n means speed. Okay, then Pb means bearing pressure. So what is the use of this pressure? Okay, so we can easily find out the n value, small n value from, so Pb formula. Okay, then so torque, first calculate or determine torque required, that means capital T, the stress in the screws, that means shear stress. Next one is the compressive stress, then maximum shear stress. Enough. The number of threads of nut in engagement with screw, that means small n. Okay, so first one is torque required. So torque required. Okay, so what is the formula of torque? So then T equal to, so T1 plus T2, then T1 equal to, so P into D by 2. Okay, so P means W into tan alpha plus pi into D by 2, then W value already given, then tan alpha plus pi. Okay, so alpha and pi not given, so first of all calculate the alpha and pi, so by using so tan alpha formula. Then next one is so tan pi equal to mu. Okay, from that relations, so calculate so alpha and pi, so then alpha equal to, then pi equal to 11.3. then next, okay, so substitute in T1 formula, so we get something answer 39502.77 Newton mm. So then T2 equal to, so mu1 into W into R, so mu1 given in question, so W known value, so R also known value, so mean radius R1 plus R2 by 2. Okay, so why we are taking this condition R equal to R1 plus R2, so this is the wear condition given in question. Okay, then T2 equal to 26250 Newton mm. Okay, so then complete total torque equal to 65752.77. that means T1 plus T2 equal to in terms of mm, so this is the in terms of meter. Okay, then second condition, so stresses, so first calculate the direct stress. Okay, so what is the formula of direct stress? Sigma C equal to W by AC. So this formula available in data book. Okay, so sigma C equal W by AC, W by pi by 4 into DC square, so DC is the unknown value. Okay, so by using this relation, so calculate the DC value, so we can calculate DC values, DC equal D0 minus P, so D0 is the outer diameter, so given in question, so P means pitch, substitute all the values, substitute in sigma C formula, then sigma C equal 31.83 Newton for mm square. Then next, direct stress completed. Then next one is shear stress. Okay, so what is the relation of shear stress and torque? Then T equal pi by 16 tau into DC cube, then DC equal 20, then tau, so calculation characteristic, then so T already completed, then T equal to 65752.77. so all the values now, all are the known values, so that substitute in tau formula, then tau equal 41.859 Newton for mm square. Then maximum shear stress, after that calculate so maximum shear stress, then so we know that sigma C and tau value, so these two values substitute in tau maximum formula. Then finally, so third one, number of threads of nut in engagement with the screw. Okay, so we know that one clue, so that is the bearing pressure, so then PB equal W by pi and dt. Okay, so N is the number of threads. Okay, so T means thickness, so thickness of thread, T equal to pitch by 2. Okay, so then so T is the known value, so N is the calculation value, so PB also known value, so all values substitute in PB formula, so finally we will get something N, so N equal 9.776, that means approximately so 10. So number of threads of nut in engagement with the screw is 10. So these are all formulas available in data book. Okay, so data book, the page number is 9.17, Jalaluddin book.